Hello. So today we're going to be talking about how we use the mean product method to solve quadratic equations. Now, if you saw my other video, we used the mean product method to solve quadratic equations that had irrational roots. But the mean product method can be used to solve quadratic equations with any type of roots. And so today we're going to be looking at a different kind of quadratic equation, and let's see what kind of roots we get. Now, here we have a quadratic equation, 3x squared minus 2x equals negative 2. Now, we need to, in order to use the mean product method, we want to rewrite this equation in the form x squared plus bx plus c equals 0. It's not quite standard form. Standard form is ax squared plus bx plus c equals 0. And so in this, if we have a coefficient in front of the x squared, we're going to divide by that coefficient throughout the entire equation so we can get the equation in the form that we want. So here, our first step would be to get the equation equal to 0. So we're going to add 2 to both sides. And we're going to get 3x squared minus 2x plus 2 equals 0. Now, we need to divide this equation by 3. So we're going to get x squared minus 2/3 x plus 2/3 equals 0. Now, we see fractions in this equation. Don't panic, because we can use a calculator to help us do the operations with fractions if necessary. So let's see what we do now. We have the equation in the form x squared plus bx plus c equals 0. We know that if the equation is written in this form, we can find the sum of the roots and the product of the roots. So in general, if we have the equation x squared plus bx plus c, we can say that the sum of the roots is negative b. And the product of the roots is c. So in this case, we can see that the product of the roots is 2/3. And the sum of the roots is negative b. So that's negative 2/3, which is positive 2/3. Now, we can draw a diagram to represent this. This horizontal line represents the line where we can find the roots, x sub 1 and x sub 2 of our, here's our parabola, here is the axis of symmetry for our parabola. This distance is u, which represents the distance from the axis of symmetry to one of the roots. We're going to assume that u is non-negative. We're only interested in the distance here. So we don't need to worry about a u value that's negative. We'll call this value m. So m represents the axis of symmetry here. And so in this case, we can see that m represents the average of the roots. It's midway between the two roots. And so here the diagram is really important in helping you to remember what m represents. So in this case, this is going to be 2/3 divided by 2, because that's half of 2/3. Well, what's half of 2/3? It's 1/3. Now, there are a couple of ways of doing that. You could think about it that way. Half of 2/3 is 1/3. You can put this into a calculator. You put 2/3 into the calculator. You take your answer, divide that by 2. One way or the other, you're going to get 1/3. You could also do 2/3 times 1/2, and you will also get 1/3 as your answer. So the average of the roots is 1/2. And so we can see from this diagram that x sub 1, the root that's on the left side, is going to be m, which is 1/3 minus u. And x sub 2, the root on the right, is going to be 1/3 plus u. Now, we call this the mean product method. Well, we just used the mean to write equations for the roots. Now we're going to use the product of the roots. Remember, the product of the roots, which is x sub 1 times x sub 2, that's equal to c. We just set that up here. The product of the roots, we said before, was 2/3. X sub 1 is 1/3 minus u. X sub 2 is 1/3 plus u. And so we can use a box to multiply and again, if you once you get more familiar with this method, you can skip this step and just go directly to the next step. 1/3 times 1/3 is 1/9. This is minus u squared. This is minus 1/3 u. This is plus 1/3 u. That equals 2/3. Now we're going to get 1/9 minus u squared equals 2/3. So we want to solve for u. So we can get the u squared over to the right side because we like the coefficient of u to be positive. That makes things less confusing. So we'll add 2 u squared to both sides. We will subtract 2/3 from both sides so that this adds up to 0, this adds up to 0. You're going to get u squared equals 1/9 minus 2/3. So 1/9 minus 2/3, again, something you want to put into the calculator if you have trouble figuring this out. You're going to get, that's going to be negative 5/9. So if this is negative 5/9, then we take the square root of both sides. U is equal to negative square root of 5, square root of negative 5/9. So using the division property of radicals, that's going to be square root of negative 5 over the square root of 9. So that's going to be square root of negative 5 is the square root of negative 1 times the square root of 5. The square root of 9 turns out to be 3. And so we remember that the square root of negative 1 is I. And so u turns out to be square root of 5 over 3 times the square root of negative 1, which is I. And so our final answer is that the roots are x sub 1 equals 1/3 minus u, which is square root of 5 over 3 times I. And then x sub 2 is 1/3 plus square root of 5 over 3 times I. So that is our answer. Now, the nice thing about this is that if look carefully, you'll see that our answer was supposed to have been written in simplest a plus bi form. And with the mean product method, you will always get your answers in the a plus bi form. You'll always be separated here, that a turns out to be the value of m, the mean of the roots, and b turns out to be the value of u, which is then multiplied by I.